All right, let's take a look at how do we calculate the z-score, right? Like I said, the z-score tells us how many standard deviations from the mean an observation, or what your data point that you're looking at, is away from the mean, either above or below. If your z-score is positive, that means you're above the mean. If your z-score is negative, that means you're below the mean. That's all it is. So let's take a look here. For the earlier example we saw, right, the mean was about 80 and the standard deviation is about 6. So we'll write that down. Right, so we'll write that down. The mean is equal to 80 and the standard deviation is equal to 6, just for this example. And by the way, thank you again, Brenda, for reminding me. I would have forgotten completely. All right, so the z-score is this equation right here. The value that you're looking at minus the mean divided by the standard deviation, right? That's all that is. So z is going to be equal to the data that you're looking at is, let's say, for Romero's score, which is 86, minus the mean, which is 80, divided by the standard deviation, which is 6. You know how to calculate the mean and the standard deviation, but for our notes today, I'm going to be giving you the mean and the standard deviation just to make it easier for us to calculate this guy right here, which is called the z-score, which is short for the standard score, pretty much. I don't know why they went with z instead of s, but that's what they went with. So 86 divided by 80, I'm sorry, 86 minus 80 divided by 6 is going to be this guy right here. So let's go ahead. Let me turn on this calculator. Right, and let's see here. This is going to be 86 minus 80, which is 6, divided by 6, which gives me a standard deviation of z-score of 1. So that number is positive, right? And that tells us that Romero did better than the average, and he did better than the average by about 1 standard deviation. Okay, that's all that is. Yeah, the standard score, or the z-score, represents the number of standard deviations a given value x falls from the mean. Excuse me. And that's given by this formula right here. They write it out using the symbols just because it's easier than writing out the whole words, but it's the same idea. Whatever your score that you're looking at that you care about, that's going to be your x value when you're calculating your z-score. And then the mean is just, well, the average that you calculate from your data, and the standard deviation, same thing, is just what you calculate from looking at your data. Okay, a z-score can be negative, positive, or 0. If a z-score is negative, then the data value you're looking at is below the average. If it's positive, then the data you're looking at is above the average. And if it's 0, which is really neat to see, when your z-score is 0, that means that your data that you're looking at is exactly equal to the mean. You're doing perfectly average compared to everyone else. Right, so let's do this right here. Let's take a look here. So looking at the test scores here, I'm gonna do 1 and then you guys can do number 2, right? Given from the ones that we do, just to keep our lives easy, I know that you guys calculated the average earlier and it was a little bit different, but I'm just gonna go and let's just do with the easy mean, and let's say it was 80 instead of 79.9, and the standard deviation was equal to 6 instead of 5.95, just to make the math easier for us, okay? We don't know how to do that on the test, no, but I'm just letting you know right now. For our examples here, for the first time we're learning this, we're keeping it nice and easy numbers, okay? So let's go over here. And let's see here. I'm looking at AO's score, and AO's score here is 93, right? I want to calculate his z-score. So his z-score is going to be equal to the mean, I'm sorry, the data that we're looking at, the value that we care about, minus the mean divided by the standard deviation. Well, the value that we care about is 93. That's going to go here. The mean that we calculated earlier was about 80. We're just going to use 80. And the standard deviation is 6. So we plug those values in. So this is going to be 93 minus 80 divided by 6. Right? Which is going to come out to be 93 minus 80, which is 13. Divide that by 6. And that gives me a z-score of 2.16 repeating, or 2.17. That means that AO is doing better right? It has a z-score of 2.17, which is, you know, on the top side of it. He's pretty far from the average, right? He's not hella far, but he's pretty far. And that's how you calculate your z-score. And that's pretty much the idea. Your z-score is just, like I said, is a standard score to help you measure. So I know some of you guys are like, knock me. I could have just looked at Ayo's score and said he did way better than Romero, right? But now I have mathematical proof that not only did he do way better, he did a whole standard deviation better than Romero. Okay. Anyways, don't worry about the analyzing part. Just let's deal with the calculating part. Can you guys calculate the z-score for Reyna real quick? I follow this example, but do it for Reyna's score now. Can you guys calculate what Reyna's z-score is going to be? And if you guys could type that into the Pear Deck real quick. So I'm going to go ahead and switch the screens on the Pear Deck. Give me 1 second. I'm going to use that slide, but I'm going to have you guys type in a number for me. Yeah, so go ahead and type in a number for me. Which is this one right here. There we go. You guys just type in what is the z-score for this one. Let's see what you guys get. We already got one person with an answer. Beautiful. Keep going. M is still 80. Yes, yes. M is still 80 and the sigma is still 6. We're going to be using these values for Reyna's example. So can you guys do that real quick? See what you guys get. Let's see what we got. What we got. Majority of you guys are just going with, it looks like about -1. It looks like some of you guys are getting. Yeah, not bad, not bad. Let's take a look. Let's compare your answers with what I get. 2 are out of this range. Oh, let's zoom out a little bit. Okay. Some of you guys went with -1, and some of you guys went with -1 point something. Devine's going with -1.3. That's not bad. Let's take a look. Reyna has a score of 72 minus the average, which is 80, divided by the standard deviation, which is 6, which is going to give me -8/6. I don't know what that is. Type it into the calculator. -8 divided by 6, and that gives me -1.3 repeating. -1.3 repeating. How do I know where to stop on my z-score? Traditionally, they go to 2 decimal places, just to give you a heads up. That's why I stopped it at 2.17, and this one is -1.33. But I will never mark you wrong if you give me more decimal places. If you had written -1.33333, I would give you the credit on that as well. Just traditionally, those z-scores, and don't worry about why I go to 2 decimal places just yet. Well, actually, I should just tell you. The reason why we go to about 2 decimal places for your z-score is because the tables that we have when we look up the z-scores go to only 2 decimal places. That's all it is. You can go further though. The more decimal places, the better, right? If you're ever doing math problems, don't be lazy about. If you're not lazy to do all the work, don't be lazy on giving me the answer, right? Give me all the extra decimal places on there. And you say, but knock me, you just wrote down as a 6. I know I was cheating on there a little bit, but that's just because I wanted us to have easier calculations than with these decimals. But then I realized I should have just had. Anyways, that's the point. So anyways, yeah, that's good. If you put down -1.3, that's beautiful. You put down -1.33, that's even better. If you put down -1, that's being really lazy. Don't round that much. Round to the second decimal place. Don't round to the whole number. I know some of you guys are used to rounding to whole numbers, but for statistics, we actually want to go to more decimal places to be more accurate when we calculate these things. Anyways, so let's take a look here. The day after receiving Romero's statistics score of an 86 from Mr. Nakami's class, Romero earned an 82 on Ms. Janota's physics test. At first, he was disappointed. Then Ms. Janota told the class performed close to a normal distribution with a mean of 76 and a standard deviation of 4. Right? So in Mr. Nakami's class, right, in Mr. Nakami's class, Romero's standard score, right, was an 86 minus an 80 divided by 6. So he had a z-score of 1, all right? What was his z-score in Ms. Genota's class then? What was Romero's z-score in Ms. Genota's class? In Ms. Genota's class, what did Romero score on Ms. Genota's test? Right? He scored a what? An 82. That's his value that we're focused on. It's the value of his score. We're comparing that then to the mean of Ms. Genota's test scores and the standard deviation of her test scores. So what is this equal to? This is equal to 82 minus 76, right, divided by 4. You see that? Sometimes you got to pay attention to which one you're looking at. In this case, the mean and the standard deviation is for a different test this time. And we're comparing that to see what his z-score was for Ms. Genota's class. And when you calculate this using those values, right, you get 82 minus 76 equals 6. Divide that by 4, and you see that his new z-score for Ms. Genota's test was 1.5. So which tests did Romero actually perform better relative to the class? Now, you'll see Romero's score looks like it's better in my class, right? He got an 86. But that's right, Demai. In Genota's class, he did better relative to his classmates. I know that it's like 82 doesn't seem that great compared to the 86. But if you compare it to the class as a whole, the z-score here is greater than the z-score here. Relatively speaking, he did better in Genota's class, right? And some of you guys will probably realize that, and you'll be like, well, that kind of makes sense, right? If the class average was a 76 in Genota's class, and the class average was an 86 in Mr. Nakami's class, that means that Mr. Nakami is too nice and he needs to make more difficult tests, right? That's too high of an app. No, I'm just kidding. I'm saying is that when you compare it with the average of everyone else in the classroom, right? He did better in Genota's class than in my class, right? I can't have that happen. I got to make my test more difficult, right? Just for you guys, and then have you guys, work harder. No, you guys agree? No, that will have a negative impact. No, don't do that. You sure? I feel like it's a good idea. Do you know what they think averages should be, by the way? Like old school thinking was that the test should be so difficult that the average should be around a 70. If it's not around a 70, that means your test is too easy. This is old school thinking. I hated this thinking. If everybody got a 90, then something was wrong with the test because it didn't test correctly. And I was like, how are you measuring that? Like, how does that make sense? But this is like way before your time. Who thought that was okay? Yeah, that's what I thought. Like, that should not be the case. If everyone got a 90, that means that everyone understands it and everyone did a good job, right? But yeah, that's old school thinking. Old school thinking. Don't worry about it. I don't do that to you guys. If I see that the average is like a 90, then I'm happy. If I see that the average is a 70, I'm still happy because you guys are in there taking the test and you're working with me to, do better. I'm assuming. All right. Anyways, analyzing z-scores. When a distribution is approximately bell-shaped, you know from the empirical rule that about 95% of the data lie within 2 standard deviations above the mean. Meaning if you go 2 standard deviations above and 2 standard deviations below, you get about 95% of the population, right? So when the distribution's values are transformed to z-scores, about 95 of the z-scores should fall between -2 and 2. So this is just fancy talking. Basically, if you get a z-score that's like -1.9 or positive 2.9, you're within a decent range. You're not that far out. But if you get a z-score that's above 2 or below -2, then you're within this thing that's in about 5% of the range. You're out there, right? There's only like 5% of people who get a z-score that's bigger than 2 or less than -2, and we consider that to be unusual. It's not like freaky or anything. It's just not normal, right? They use the word unusual because normal we use for the bell-shaped curve. Anyways, it's considered unusual, right? It's kind of far. And this is where I was talking to you guys. If you go to 3 standard deviations above or below and you go past that, if you get a z-score of -3.5 or positive 3.5, That's considered to be very unusual. And that's like an easy example is like if you're looking at your shoe size, average shoe size is for a male is about, I think, like a size 9 or a size 10, I'd say, with a specific standard deviation, right? And if you have a you calculate your shoe size with that, your z-score would probably be around like on normal z-scores would be around like 1 to 2, right? With a few people with a z-score of higher than 2, meaning they have like a shoe size of like 14 or 15, right? If you have a shoe size 15, that's a really big foot, but it's not like it's just a little unusual. It's not like very unusual, right? If you have a size like 15 or 16. If you go 3 standard deviations or more, like you have a z-score of 3, 4, or 3.5 or 4.5 or something like that, that's considered very unusual, and that would be like Shaq's foot. Shaq's shoe size is like a size 23 or something like that, 22 or 23. And if you were to calculate his z-score but from his shoe size, his z-score would be somewhere along the lines of like 5 or 6 as a z-score. And I'm telling you right now, if you, like I said, if you don't believe me, if you calculate and you get a z-score of 3 or more, and you get a standard deviation of 3 or more, the official term is basically that's hella far from the average. So if you saw and you got a z-score that was 3.5, you'd say, dang, that is hella whatever it is that you're looking at. So if you had like a, like a shoe size that was a z-score of 3 point something, you'd say that foot is hella big, right? And I know some of you guys like, that's not the real term, and it might not be, but I promise you, if you go off to college and you take a stats class, yeah, hella big. If you go to stats in a college course and you start talking about standard deviations, ask your professor, would it be fair to describe something that's 3 standard deviations away as hella far from the average? And, you might be worried like what he's going to think, but I'm pretty sure he'd agree. Like, yeah, that's about right. 3 standard deviations, hella far. It's very unusual. And they do happen, by the way. They do happen. It's not something that you can say like, oh, it's impossible to have something that far away. But it is possible, right? Like we talked about height before. Average height for a male, right? Did we look this up? Average height for a male was 5'9", right? We made up the standard deviation, but the standard deviation is about 2 to 3 inches. But we know that there are people who are way taller than the average by more than just 1 to 2 standard deviations. We know that there are people that are 7 feet tall, and that's about 3 to 4 standard deviations away. So that means the z-score would be about 3 something, which means that that person is hella tall, right? And stuff like that. That's pretty much what the z-score is. It's just a number that the closer you are to 0, the closer you are to the average. The further away you are from the 0, the further away you are from the average, right? And about 2, a z-score of about 2 or more is considered already kind of unusual, kind of far. But if you go to 3 or higher, that's very unusual, and that's very far. I'm sorry, hella unusual and hella far. All right, I'm talking too much. Let's actually do a couple problems, right? I know that's so much talking, but when you do the calculations for these z-scores, you're gonna realize like, this is easy, right? This is easy. So let's take a look at this problem. Let's take a look, see if we can calculate the z-scores for these examples right here, okay? Let's say here we got the mean speed of a vehicle along a stretch of highway is 56 miles per hour. So they tell us the mean is 56 miles per hour, right? So you write that down somewhere. What symbol do you guys want to use? Is this a sample or is this a population? Doesn't say. We're just going to assume that it's the population because it's the speed of all the vehicles along the stretch of highway. So we're going to write that down. The mean for this one is going to be equal to 56 miles per hour. We're just assuming, right? With a standard deviation of 4 miles per hour. So the sigma is going to equal to 4 miles per hour. So you write that down, right? Write that down. So the mean is that, and then the standard deviation is that right there. You measure the speed of 3 cars traveling along this stretch of highway as 62 miles per hour, 47 miles per hour, and 56 miles per hour, right? So let's go ahead and get that down. So we have 3 z-scores we got to calculate. The first one is for the speed of 62 miles per hour. So the first one, x is equal to 62, and I'm going to calculate the z-score for that one. Remember, your z-score is just your value that you care about, that you're looking at, minus the mean divided by the standard deviation. So to calculate the z-score for 62, I would say that z is going to equal to 62 minus the mean, which is 56, divided by 4. And again, you just plug this into your calculator and see what you get, right? Plug this into your calculator and see what you get. So let's go ahead here and take a look. I have here 62 minus 56. That's going to give me that number. Divide that by 4. And I have a z-score of 1.5. Looking at that z-score, this person who's going 62 miles per hour, is he going very fast compared to the average? Kind of fast, or not that fast at all? With a z-score of 1.5, that's kind of fast. It's not very fast. It's just kind of, right? If it was a z-score of 2, then I'd say that's fast. It's not even kind of fast. It's fast, right? If you have a z-score of 3, then you say that's hella fast. But this guy's going 1.5 above the speed limit, standard deviations above the speed limit. Is he going to get a ticket? Probably not. Probably not. Right? 1.5 as your standard as your z-score means that he's probably not going to get a ticket. And if you look at the values, it kind of makes sense, right? If the speed limit, this is a weird speed limit. Let's say the speed limit was 56, right? I don't know where the speed limit would be 56, but let's say it is 56 and you're going 62, you probably wouldn't get pulled over. 4 standard deviations would be illegally fast. Actually, even 3 standard deviations might be illegally fast. But let's take a look. Actually, we're not going to have that in here, but we could, you know what? That'd be a fun problem to calculate. Do you know how fast is actually 3 standard deviations for this example would be? How far away is 3 standard deviations from 56 in this example here? That would be 60 miles per hour for 1 standard deviations, 64 miles per hour for 2 standard deviations, and 68 miles per hour for 3 standard deviations. So if you're going faster than 68 miles per hour in a 56 zone, which is a weird number to think about, but if that's the case, you're going 3 standard deviations above, you're going hella faster than the average speed. You're probably going to get a ticket for that. But yeah, that's the idea. My instructor made me do 90 in the carpool lane. Okay, so in the carpool lane around here, the average maximum speed limit is about 65, right? I think the speed limit is 65 miles per hour. So you were doing 25 over the speed limit, which means you were going, yeah, I'd say that's hella fast. Why? Why did your instructor do that? Did your instructor just want you to see what it's like to go 90? Or was it just one of those things that's just like, he felt comfortable with your driving and was just like, you want to go fast? That seems ridiculous. It just happened. Were you freaking out a little bit or were you okay? He was on X Games mode. That's nuts. When you're first learning how to drive and you go over 70, it's already feeling kind of weird. I mean, the cars behind me were going fast. Yeah, then yeah, they could have been pressuring you. Freeway is scary. I still remember the first time I drove on the freeway. You gotta be careful when you check your blind spot to make sure your steering wheel is going where it's supposed to. A common thing that, and then the one thing I did was when I checked my blind spot, I'd like turn my head to check my blind spot, which caused me to turn my hands, which then caused your car to swerve slowly into the lane next to you as you're trying to check your blind spot, which is terrible because you're checking your blind spot so you can see if you can go into that lane or not. And if there's a car there and you're swerving already, you're gonna like crash into the lane. So that took some practice from me, which is checking your blind spot quickly without turning the wheel. I know that's like, not just don't turn the wheel. It's like, I know not to turn the wheel, but yet it happened. Doesn't happen anymore. I know the stereotype out there is that Asians are terrible drivers, and that's a little racist. Semi-true. All right, guys. Can you guys try this one? You don't have to put this one in the pair deck. Can you guys calculate the z-score for 47? And then if you figure that one out, can you calculate the z-score for 56? Can you calculate those 2 z-scores for me using this equation right here and using the mean of 56 and the standard deviation of 4, right? So that goes into there and that goes into there. The only thing that changes is the value for each of those ones. Can you guys do that real quick? Figure out what is the z-score for 47 and what's the z-score for 56. And don't worry if it comes out negative. 47 is slower than the average speed there. So this person is going slower than the average speed on this highway. So you should get a negative z-score, right? Whereas a positive z-score means that you're going above the average, right? So keep those in mind, below the average and above the average there. You guys can see that. Oh, you guys excited after today? You get tomorrow off? We're almost there, guys. We only got like 22 more minutes left in this class. After 22 more minutes, then we have, your day off on Wednesday. I'm still trying to figure out what we're going to do. I know we're not going to the classroom anytime soon, but I kind of want to go back to the classroom and teach from there. Teaching from home is nice and all, but I don't know. I feel like, I don't know. I feel like I'm in a little rut, you know? I don't know if you guys feel the same way. You're probably just like, nah, you're nuts, knock me. You sleep in and roll over at 8 o'clock and just log into class. I'm there. Which is nice for you guys. And I don't know. I kind of miss, interacting with people. But it is what it is. We gotta do what we gotta do. You guys heard the good news, right? The vaccine that was being tested by Pfizer is being read as that it is 90% effective. I don't know if you guys saw that, which is a good thing. 90% effective, by the way, is a little under 2 standard deviations away from the average there. So it's not hella, positive yet, but it is still pretty good news to catch, right? We see that. I would like to go back to school too. Yeah, it would be so much nicer. But then are we going to do like the whole thing of like everybody's going to have to be separated, distance apart? But what if I don't take the vaccine? Do I get kicked out of the country? No. And Calvin, actually, to be fair, chances are the vaccine won't be readily available for everybody anyways, right off the bat. I think the first batch of those vaccines are going to go straight to doctors and first responders, people who are working in the emergency rooms and all that. I'm pretty sure they get the first batch of it. Second batch would then be probably to other essential workers, like people who are working for the post office or deliveries, things packages and whatnot, people who are driving around a lot. They'll probably get the second wave. Third wave will finally be, I think, students. I think. Actually, no. Old people have to be in there at some point. I don't know. It'd be mixed in somewhere. But by the time we get it, I think it'd be like pretty late. But eventually. So you don't have to worry about it if you don't want to get it just yet. But eventually, you should consider getting it. Just like all the other vaccines. I feel like it will be optional, like the flu shot. Here's the thing, though, Michael. Flu shots. Do you know what the percentage is for flu shots being successful? Yeah, needles suck. Flu shot hurts too. I don't know if you guys ever got it. They don't care about it. They just jam it into your arm. And that's how this vaccine is going to be like as well. You get sore for a little bit, but flu shot, the percentage is only like, I want to say like 50 to 60% effective. 50 to 60%, which is, if you were to look at it, it's about 1 standard deviation away. Sky, we were wishing you a happy birthday earlier. Did you not catch that, Sky? I asked you earlier, is this your birthday? But I'll say it again. Happy birthday, Sky. Yes. Yeah, guys, you guys type into the chat? Wish Sky a happy birthday today. Happy birthday, Sky. Happy birthday. Yay. Are you going to do anything today, Sky? Okay, let's have a happy birthday. Calvin, happy birthday. Oh, Grace. Happy birthday, happy birthday. What you doing today, Sky? Type it out. Going anywhere, doing anything special? Or you can't share, Going to the Lobster? The Lobster or Red Lobster? What's the Lobster? That sounds good though. Lobster. I do love me some lobster. All right, so as you're typing that out, I'm going to go ahead and start working on these problems. So hopefully you guys were able to calculate these Z-scores. I didn't put it on the Pear Deck for you guys. I just got distracted there talking to myself about random things. It seems to be the norm, right? I don't know if you guys caught on to that yet. But let's go ahead. Let's take a look here. We're looking at 47 minus 56 because that's the average speed that's on there divided by 4. So you guys should have got your z-score for this one right here, right? Is going to be, turn on the calculator, 47 minus 56, right? The lobster. All right, I got to check that out. Is going to equal to that. Divide that by 4. And this person is going negative 2.25 standard deviations below the average. And negative 2 is already considered very slow. Negative 2.25 is it's not hella, I shouldn't say very, it's unusual. It's I'd be annoyed if I saw this guy on the freeway pretty much going at that speed. In your opinion, when do you think the vaccine will be ready? Honestly, that's something I don't know, but the fact that they're at that percentage right now, and this is November, it probably won't be ready until like realistically, probably like March or April. And that's being like super like positive about it. It probably will be a little bit later than April. But yeah. It's good news. So we got to look at it that way, right? Honestly, they probably like, that's like the first big thing that was published is the fact that it got up to like 90%. Like I think other ones, like they weren't even getting to like human testing. Oh, guys, testing on drugs of stuff, like they take years sometimes, guys. They literally take years sometimes. So, it's nice that they're kind of speeding it along, but the thing is you don't want it to be sped along and not work correctly. So you just, you hope that they can speed along, but you also want it to be effective, right? So you want, it's slow, but you want it to work. You don't want it to be like making this claim and then everybody takes it and, we have a zombie apocalypse on our hands because they rushed through it, right? We want them to make sure that it works correctly. All right. So this person who's going 56 miles per hour is driving the same exact speed as the average of this one. So when you calculate the z-score, what did you notice? What did you get? Going to be a Teenage Mutant Ninja Turtle after the vaccine. I don't know if it'll turn you into a turtle. I don't know about that. By the way, right? Those turtles were ninjas not because of the drugs that they took. They were ninjas because of the rat that taught them ninja. Ninjutsu? No. That taught them how to fight. Master Splinter taught them how to become ninjas. The mutant part was the drugs. Anyways, this one gives you a z-score of 0, which makes sense because he's going the same exact speed as Sensei Nami. This goes in the same exact speed as every other car on there, right? As the average. So he's not going faster than the average, not going slower than the average, so the z-score is 0 there. Hella average. That one's not okay. That one won't work. It's not the hell average. It's just that right there. All right. I want you guys to try this one. Let's go to this Pear Deck right here. You guys try this one. There's 3 problems here, right? And I'm going to list it out, but I want the standard deviation. I'm sorry, I want the z-score for all 3 for this one right here, right? So let's list it out. The mean of this one is $70. The standard deviation of that is $80. Can you calculate the z-score for these 3 values right here? So I want you to tell me the z-score for when somebody who's paying a utility bill of $60, what's their z-score? Tell me then for the person who's paying $71, right? What's their z-score? And then tell me someone who's paying $92 for their utilities, what's their z-score when the average is 70 with the standard deviations of 8? So go ahead and I have that in there. Can you guys go onto the Pear Deck for me and just draw this out or type it out for me what the answers are. So I'll put the back in the chat. For those of you who closed it or might not still have it open or who haven't clicked on it at all, can you guys go in there real quick and start typing what you have for that? Those 3 answers. Give me those 3 z-scores. Should be fairly quick, guys. I put it back in the chat. Just give me the answers if you can. If you want to go above and beyond, show me what it is that you are calculating, right? The example up here. Can you show me what numbers get plugged into what, and what is subtracting with what, and what is dividing by what? What? I'm losing my mind a little bit. All right. But yeah, I think what do I think? I think Thursday. I think Friday maybe, or Thursday. I'm gonna start moving stuff to school. I know that you guys can't be in there. By the way, where's your dog? She's running around about. I think she's just napping. It's like cold, so she's probably in her beanbag. Oh, that's the other sad part though. If I go teach at school, I won't have dog with me. And I'll probably have to put on actual pants. I'm wearing pajama bottoms right now. I don't know if you guys can't see, right? That's the beauty of teaching on the screen. You only see my upper. Yeah, I have pajama bottoms on and my Jordan slippers on. Actually, I can show you my slippers. You probably see the let's see here. So I see my pajama bottoms. Can you see my slippers? Let me get that. Yeah. So looks like I'm dressed nice, but it's just the top part. Now we have video recording of the fact that I'm not fully dressed. I have dress pants ready. It wouldn't make sense for me to wear it if you can't see it, right? But that's going to be for if I ever decide to go back to the classroom. Maybe I'll wear that, get back in there. All right. You guys got these Z-scores for me? Let's see here. Jenny, you clicking on there? Are you starting to write it? Nice. Interesting color choice. Oh, God. It's so yellow. Kevin, I think that's the first Z-score. That's awesome. I like it. Giselle, I love that you're drawing it out and showing me what numbers get plugged into what. That makes it easier for me to look at. That's beautiful. And those are the only people who've clicked down here. Really? Only 3 of you guys? 4 of you guys clicked on here? Come on, guys. Oh, Demaya's just like, I'm just typing in here. That's fine. That works too. Just because it's not working too well for you. All right. I appreciate it. And yeah, looking good. Mine is still loading. All right. That's okay then, Christina. You guys can just type it into the chat if you guys want to do that. And if you guys agree with Demaya, you could just type it in there as well. I guess it is, kind of sucks that it doesn't work too well for everybody. But I do appreciate those who do click in there and go in there. Jenny, are you drawing with like the highlighter tool? That's pretty cool because it looks like a water painting, but looks cool. All right. Let's go. We'll finish this up, and I'll do the last we'll do, and then we're going to be done with 2.5. We're going to be done with 2.5. So hopefully you guys see here, right? We have the mean, we have the standard deviation, and we have the values that we care about. So for this first one, right, just plug it in. It's going to be 60 minus 70 divided by 8, right? Plug that into a calculator. And Jenny, I'm going to trust your answer here. And it looks like it matches up with Demaya. We're going to go with negative 1.25. So if it's wrong, you guys can just blame Demaya and Jenny. All right, so they got that. And I'm going to trust them that they got that right. And if it's not right, again, go yell at them, not me. All right, so let's go to number 2. All right. This person is paying their utility. So this person, the first one's paying cheaper than the average. This guy is saving money. He's paying less money than the average on his utility or her utility bill, right? The next person is paying $71. And let's see here, the Z-score is going to be 71 minus 70 divided by 8, right? Which gives me a Z-score of 1/8, which it looks like you guys are saying is 0.125. And so it's positive, so he's paying more than the average, but barely more, right? His Z-score is less than 1, I would say. And so, I mean, that's what you guys calculated. And I would say then that means that he's barely paying more than, just a little bit more than the average. Not a lot, just a little bit. Now, this third person is paying $92 a month for their utilities. This guy has left the water running or the gas running or something running. This guy's burning through his money on this utility bill compared to everyone else. And if I compare it and calculate the Z-score for this last one, right, use the toilet too many times. This person got a Z-score of, let's plug it in real quick. just to show the work, 92 minus 70, right? Gives me that z-score right there. Divide that by 8, and you get a z-score of 2.75. That's almost 3. That's almost 3. That guy's paying not hella a lot more, but a lot more, right? He's almost at the hella mark, right? He's at 2.7. He's almost at the hella mark, but it's definitely a lot more. And you can kind of see that, right? If the average is $70 per person or per household, right, with a standard deviation of 8, this guy is paying so much more, 2.7 standard deviations more. What is he doing? Alan's saying that he used the toilet too many times, right? We don't know, but he's doing something that's eating up his utilities bill. This is actually an old problem, so I don't know what utility bills go for nowadays. Like I don't know, like the gas bill usually isn't that expensive, right? It's like around $20, I think. You guys are gonna have to look into this at some point. You guys when you guys move out and pay your own bills, you're gonna have to figure out how much you have to pay for gas, how much you have to pay for power. If you find an apartment, you probably don't have to pay for water. But yeah, utilities, man. Going to UC El Camino. Yeah, but knowing that, you're gonna have to probably start helping out around the house too. Or at least some parents make you guys help around the house, so you're gonna have to start growing up and looking at these bills. Bills. All right. There's only 2 more examples here, and it's the same concept, except you're going to do it twice, right? You're going to calculate the z-score for best supporting actress, and you're going to do it for best supporting actor. So you're going to do it for each one of those ones. And let's just do that real quick here. So in 2009, Heath Ledger won the Oscar for best supporting actor at age 29. So Ledger, right, his age was 29 when he won the best supporting actor role, right? Penelope Cruz, right, that year won for best supporting actress at the age of 34, right? For her role in Vicky Cristina Barcelona. I've never seen that movie. I've never heard of that movie, actually. I've heard of The Dark Knight, but I've never heard of Vicky Cristina Barcelona. Anyways, not important. The mean age for all best supporting actor winners is 49. So that tells me the mean for males is 49.5, whereas with a standard deviation of 13.8. That's right here. Hey, wasn't he the Joker? Yeah, that's what he won the role for. He won the role for Joker. That's right, Michael. Yeah. The mean age for best supporting actress is 39.9. So it's a little bit younger for the mean female lead of supporting actress right there. So that's going to be 39.9. And then with a standard deviation there of 14.0. So all I'm saying is if I was to calculate the z-scores between the two, right, I would just use these different values for each of one, because one is for males and one is for females. So the z-score for Heath Ledger for his age when he won the best supporting actor role is going to be 29 minus 49.5 divided by 13.8, which gives me a negative number, which means that he was below the average age of people who win best supporting actor, which, you know, you can see it with the 29 and the 49. He's about 20 years younger than the average age of the person who won it. But how many standard deviations away is that? And that's actually not that many looking at the z-score of 13. I'm sorry, the standard deviation of 13.8. He has a z-score of about negative 1.485. It's actually 5.5. I'm going to round that to 1.49. And then he's younger, right? But 1.49 isn't that much younger. It's just a little bit younger. Not that much more. And Penelope Cruz is that Penelope Cruz? I already forgot her name. Yeah, Penelope Cruz won it when she was 34 years old. She is definitely younger than the average of 39, right? But that means that her z-score is going to be 34 minus 39.9. And that's going to be divided by 14. She was even closer. Her z-score is negative as well, but it's negative 0.421. So it's negative 0.42. And that's her z-score. So she's, you know, younger than the average as well, but not that much younger. Same thing with Ledger. He was younger, but he's not that young compared to everyone else's average, right? And that's that, guys. That's it for 2.5, guys. 2.5 is done skis. There's one more example that says you try, but I'm not going to do it. That's something for you to try. Once you finish that up, you can go ahead and submit the notes now. Yeah, you can go ahead and submit the notes. And once I grade them and you see that you don't have a score in there, you can always just email me like, hey, what happened here, Nakami? I have the notes done. Just send me an email with the PDF of it if you did it using Google Docs instead of Kami. Okay, so that's that. You can go ahead and submit this. Let me go over here. Let me see if I have your homework posted or not. But the homework on there is these problems right here. Number 1, 7 through 13 odd, 17 through 20, and then 23 through 29 odd on there. So let me see here. Do I have your homework already posted? I think I don't, actually. I think I don't. Let's see here. Where do we go? Modules is the easiest way, I think, but you could also go with the other one. So yeah, 2.4 notes is here, but I don't have 2.5 homework yet. Let me put the 2.5 notes onto here, and then I'm going to add the 2.5 homework later on. It's not up yet. Yeah, you can submit the notes now, Michael. That one's done. It's not up yet, Calvin. Thanks for letting me know. I'll put that up today so you guys can start it. When you guys come in on Thursday, be ready for a review for your tests for Chapter 2. I was going to make us do a group project, but it's just not going to work out. So I'm thinking about doing a project for yourself to do over Thanksgiving break as extra credit to help you on your test scores. Let me know how you feel about that, okay? We'll talk about it on Thursday. It is 11:59. I want to make sure you guys are here on time. So I'm going to call it there, guys. Have a good rest of your day. I'll see you guys on Thursday, all right? So long, guys. Farewell.